Hi guys, thank you for watching my previous video. So today we are looking at a new chapter called Coordinate Geometry. So without further ado, let's take a look at the first question. And over here we have a question. We are asked to find the equation of the perpendicular bisector of AB, where A is given 310 and B is given 72. So with these two coordinates of A and B, so let's sketch them out so that you have a rough idea of how it looks like. And I tried to link them up, it's not straight enough, so let me redo it again using a straight line. Okay, I've got a straight line, and let me darken it. So finally I have linked up A and B. So we are asked to find the equation of the perpendicular bisector. So let me draw a perpendicular bisector out using another straight line. So please bear with me while I am drawing the perpendicular bisector. So what it means this line is perpendicular to AB and it also cuts AB into two halves. That's the meaning of perpendicular bisector of AB. So let me label this perpendicular bisector of AB. So as you can see, I'm showing that this perpendicular bisector is perpendicular to AB plus it cuts it into half. So this means we have to find the midpoint of AB. So how to find the midpoint of AB? Simply x1 plus x2 over 2 and y1 plus y2 over 2, and you get 5 and 6. That's the midpoint of AB. And with this, we first have to find the gradient of AB. So first we need to find the gradient of AB. So the gradient of AB is minus 1 divided by the gradient of, so the gradient of AB is y1 minus y2 over x1 minus x2. So let me correct the denominator. Okay, so we have 10 minus 2 over 3 minus 7, and therefore we get 8 over minus 4, which is minus 2. And now with this gradient, we can find the gradient of the perpendicular bisector of AB, because the perpendicular bisector of AB, the gradient of it times the gradient of AB should give us minus 1. Therefore the gradient of the perpendicular bisector of AB is equal to minus 1 over minus 2, which is half. Therefore the equation of perpendicular bisector of AB, I use PB to denote perpendicular bisector, is equal to y equals to mx plus c. So what we need to do here, so we know the gradient of PB of AB is half, therefore we get y equals to half x plus c, and our job is to find c. So we sub in the midpoint of AB into this equation, therefore I get my c equals to 3.5. Therefore the equation of PB of AB is equals to y equals to half x plus 3.5. A triangle has vertices A, B, C, and their coordinates are given. And given that ABCD is a parallelogram, and we are asked to find the coordinates of the point D. So for questions like this, it is better for you to sketch out all the vertices. So now I'm trying to sketch out all the vertices first. So I have a general idea of how this triangle looks like. Because the best way to do a question is try not to put everything in your brain. Try to put everything onto a paper so that you don't have so much workload in your brain, so your brain can think better. So I have drawn A, B, and C. So with this, we can start to link up A, B, and C, and we have got this triangle. And we also know that these coordinates of the point D will help us form a parallelogram. So what does this mean to us? What does a parallelogram means? So this means our side AB is equal to our side CD. And not only this, our side AD is also equal to our side BC. And in addition, we can also say that the midpoint of our BD is equal to the midpoint of our AC. So this is a very important concept for parallelogram. So in order to solve this question, you must be able to get this concept right. So let's let x, y to be the coordinates of D, and with midpoint of BD equals to midpoint of AC, so we can simply form an equation. Therefore, the midpoint of BD is 10 plus x over 2, comma 4 plus y over 2, so equals to the midpoint of AC. So for the x coordinate, 4 plus 9 over 2, and then for the y coordinate, 0 plus 0 divided by 2. So simply, we can compare the x term, and also we can compare the y term, and therefore we have two equations. So if you go ahead and solve it, you get x equals to 3, y equals to minus 4. Therefore, the coordinates of the point D is 3, comma, minus 4. So remember, if you are given a parallelogram, the midpoint of the two diagonals, they are the same. So now we are asked to find the area of the parallelogram ABCD. So over here, we can use the fishbone method. Over here, I call it the fishbone method. It depends what your teacher calls it. So for the fishbone method, which is you just take half times a stroke. So take all the coordinates and arrange it in such a manner. Okay, and then so you add up all these multiplication first. So 4 times 4, you get 16. Oh no, so it's 4 times minus 4. therefore you get minus 16, and then you plus 3 times 0 is 0, and then you plus 9 times 4 equals to 36. And from the right side to the left side, you have to minus off the summation of them. So therefore you get 4 times 4 equals to plus 16, because it's from right to left, therefore minus 16 minus 10 times 0 minus 36. Therefore you get half 40. Therefore you get 20 unit square. So now we have come to this question. So over here we are asked to find the equation of BC, and the equation of BC should look like y equals to mx plus c. So let me take out the line BC and the line AQ first. So it's good to take out and simplify the diagram. Otherwise, if you look at the original diagram, there is too much information there, you get overloaded with information and you don't know what to do. So over here, in order to find the gradient of BC, we can find the gradient of AQ first, because we know A and Q. So y1 minus y2 over x1 minus x2, and we get minus half for the gradient of AQ. And therefore, because BC is perpendicular to AQ, therefore the gradient of BC is equal to minus 1 divided by the gradient of AQ. Therefore you get a gradient of BC, m equals to 2. So now equation of BC, y equals to mx plus c. Now you can sub in your m equals to 2 in, and you can take one set of coordinates, which is your q, and you sub it into y equals to mx plus c. So you get 1 equals to 2x, your x is 4 plus c, therefore your c equals to minus 7. Therefore you can find the equation of BC to be y equals to 2x minus 7. You can only take the coordinates of q and sub it into the equation of BC, because q lies on BC. You can't take any other coordinates. You cannot take A, you cannot take P, because they do not lie on BC. Okay, now we are asked to find the coordinates of BC, right? So the coordinate of BC, and you should realize that line BC and line AB, they intersect at point B. Therefore, it's good to find out the equation of AB. So over here should be equation of AB. It's not equation of AC. So I'm correcting it right away. Because we need to find coordinates of B, therefore we will find the equation of AB first. So gradient of AB is equal to minus 1. Therefore the equation of AB is y equals to mx plus c. So over here you need to sub one set of x and y into it, and we choose the coordinates of A because it lies on the line AB. So once you sub it in, 4 equals to minus 1 times minus 2 plus c, your c equals to 2. Therefore the equation of AB is y equals to minus x plus 2. So now we have the equation of AB, and we also have the equation of BC. So in order to find the intersection points, so we just need to solve these two equations. So these two equations will form a simultaneous equation. Therefore, if you can recall, for simultaneous equation, there are three ways to solve: elimination, substitution, and graphical method. Over here, this is the graphical method we are talking about. So Therefore, you equate these two equations and you get x equals to 3 and y equals to minus 1. Therefore, the coordinates of B is 3, minus 1. I don't think I have enough space here, so I will go to the next slide and continue this question. So over here, we are to find the coordinates of C right now. And what do we know? We know that BQ to QC is 1, 2, 3. So therefore, we can use the internal point of division on your right. So simply, you can just make use of this formula. So over here, your M is your 1, your N is your 3. So let me copy down the formula first. Then what you need to do later is just sub the values into this formula. It's quite a mechanical process. You don't have to think much, just put the numbers into this equation. So over here, our M is equals to 1, our N is 3. Therefore, you see that the denominator is 3 plus 1, 3 plus 1. And let me refer to the last slide and write down the coordinate of B, which is 3, minus 1. And the coordinates of C is what we need to find. Therefore, I label it x1, y1. So therefore, our N here is 3. M is 1. So with all these, just plug in the numbers into this formula. So as I am writing or putting the numbers into these equations, I hope you try to digest the numbers I have put in. It's not hard. Basically, you just have to plug in the numbers and you will get the answers. So let's simplify the question. So we get an equation here. And let's continue to simplify this question. So after simplifying this question, you should get what I have written on the left. So therefore, you just compare the x coordinate term and you compare the y coordinate. Okay, you just compare the x coordinate term and you compare the y coordinate term. And you should get C 7, 7. So now, let's find the area of triangle ABC. So it's easy. You can use the fishbone method. So please put in the coordinates in such a manner. And from right to left, it's always addition of the multiplication. Therefore, minus 2 times minus 1, you get 2. And then 3, 7, you get 21. 7 times 4, you get 28. And from right to left, so you should minus the results. So negative 2, 7, you get negative 14. So you minus bracket negative 14. 7 times minus 1, so you minus 7. And 3 times 4, you get 12. So minus 12. So therefore, let's open a bracket and continue to solve further. You should get 30 unit square for the area of the triangle ABC. I hope you've enjoyed it. Thank you. See you again. Bye.